Welcome to another session of Advanced Calculus 2, Session 6. And this is the last session in the series of lessons for Unit 1. In this session, we shall be looking at definite integrals of vector functions. If the vector function r of t, which is defined as f of t, g of t, h of t, that is f of t, g of t, h of t are the component functions, then the definite integral of r of t is defined by integration of r of t with respect to t from a to b will be just the integration of the individual component functions as we have here from a to b. As said in the previous lessons, when we are integrating the individual component functions, all the various techniques of integration is applied. So it's a good thing to revise your techniques of integration. We have integration by parts, the use substitution, reduction method, and etc. Let's pick an example and see how this can be illustrated. We are to evaluate the integral from 0 to 1 of sine pi t, then 6t squared plus 4t respect to t. We shall do this by integrating the individual component functions. Let's start with sine pi t. So we are integrating sine pi t from 0 to 1 with respect to t. Remember, this is a composite function, a function within a function. The sine itself is a function, and pi t is also a function. When it happens like this, we integrate the outside functions, that is the sine itself, and that will give us minus cos pi t. Then we differentiate the innermost function, that is pi t, and then we use the result to divide what we have. So when we differentiate pi t, the result is pi. With definite integrals, we do not need to add the arbitrary constant of integration. It's not needed. So we are integrating from 0 to 1. We first slot in the value of t when it's 1. That's the upper limit. So that is cos pi. When t is 1, the innermost function pi t will just be pi. And when t is equal to 0, the innermost function will just be cos 0. It will be 0. So that will cos 0 over pi. We always subtract the value of the lower limit from the value of the upper limit. So there will be a minus sign here. I'm repeating again. It is the value of our integral at the upper limit minus that of the lower limit. So we now find the value of cos pi. Cos pi is the same thing as negative 1. So this expression will yield positive 1 over pi. Then cos 0. Cos 0 is positive 1. So we have minus 1 over pi. Remember here there was a negative 1 here, negative sign here already. So if cos pi is negative 1, the whole expression here will tend to be positive. But here cos 0 is positive 1. And here there is negative sign. So it's still maintained as what? Negative 1. Take note. Then we perform this subtraction. This will yield 2 over pi. We'll look at the second component function. We are integrating from 0 to 1 of 6t squared plus 4t respect to t. This will yield 2t cubed plus 2t squared from an upper limit of 1 to a lower limit of 0. When we throw in the upper limits, the 2t cubed will yield 2. And then the 2t squared will also yield 2. And when we throw in the lower limit, it will just 0 plus 0. The whole expression now can be simplified to 4. So our result of our integration will be 2 over 2 on pi and then 4. Let's look at another example. We are evaluating 4 on 1 plus t squared j plus 2t over 1 plus t squared k. So let's pick the j component. So that will be 4 over 1 plus t squared with respect to t from a lower limit of 0 to an upper limit of 1. We can take the constant outside the integral sign. And we are left with 1 over 1 plus t squared dt. 1 over 1 plus t squared is a differentiation of tan inverse of t. So when we integrate this expression, we are supposed to get tan inverse of t. So this will yield 4 tan inverse of t from a lower limit of 0 to an upper limit of 1. So we are going to have 4 tan inverse of 1 minus 4 tan inverse of 0. Tan inverse of 1 is 45 degrees in terms of degrees. And that is the same thing as 1 over 4 pi in terms of radians. And most of the times we leave our answers in terms of radians. So we are going to write this as 1/4 pi radians. So this will be 4 times the tan inverse of 1, which is 1 over 4 pi. Then tan inverse of 0 is still 0. So this will yield 0. Simplifying this expression, we are going to get just pi. Then let's look at the next one. We are integrating 2t on 1 plus t squared dt from a lower limit of 0 to an upper limit of 1. We'll use the u substitution. We'll say let u be equal to 1 plus t squared. Then the u on the t will be equal to 2t. Our dt will be equal to du over 2t. Let's take note of this because we are doing the u substitution. We can change limit. So let's do change of limits. When t is equal to 0, that's the lower limit, u will be equal to 1 plus 0 squared, and that is 1. We are still using the relation for u. And when t is equal to 1, our u will be equal to 1 plus 1 squared, and that will be 2. Good. So let's substitute these guys into the original question. So that will be the integration of 2t over u. Remember, we are replacing 1 plus t squared with u. Then instead of writing the t, write the u over 2t. Then our new limits are 1 to 2. We are going to perform some cancellations. The 2t will cancel this t, 2t. Then the expression will be remaining, will now be integrated. The remaining expression will be 1 over u from a lower limit of 1 to an upper limit of 2. We are integrating respect to u. And this will be ln u from a lower limit of 1 to an upper limit of 2. So this will be ln 2 minus ln 1. Since ln 1 is 0, the final answer will be ln 2. So the answer to this problem will be pi j, the results of the integration of the first component function, plus ln 2k. Note that in this question, there was no I component. So our final answer will be pi j plus ln 2k. Let's look at these exercises. We'll look at the first one. We'll pick the first component function, that is 16t cubed. So we are going to integrate 16t cubed from 0 to 1 respect to t. And this will be 16t raised to the power 4 on 4 from a lower limit of 0 to an upper limit of 1. And this will be 4t raised to the power 4 from an upper limit of 1 to a lower limit of 0. So this will just be 4t when the upper limit is 1 raised to the power 4. Then 4 multiplying 0 raised to the power 4. And our results will just be 4. Let's pick the second component function. Integration of negative 9 t squared. The t, the lower limit is 0, upper limit is 1. This will yield negative 3 t squared. Sorry, t cubed from a lower limit of 0 to an upper limit of 1. When we throw in the 1, we are going to get minus 3. And when we throw in the 0, we'll get 0. So the result here will be negative 3. Let's pick the last component function. Integration of 25 t raised to the power 4 with respect to t from 0 to 1. This will be 5 t raised to the power 5 from 0 to 1. When you throw in the 1, we'll get 5. When you throw in the 0, we'll get 0. So our final answer to this will be 5. We'll now bring all of them together to represent the integral of our vector function. So this will be 4i minus 3j plus 5k. Let's look at the b. We are integrating root t from 1 to 4 respect to t. Remember, this is the same thing as t raised to the power half. From 1 to 4 to t. By the rules of integration, we'll increase the power by 1 and we'll divide by the results. So when we increase the power by 1, that will just be 3 on 2. So to be t raised to the power 3 on 2 divided by 3 on 2 from 1 to 4. And this becomes 2 over 3 t raised to the power 3 on 2. Remember, this is fraction over fraction, so we reciprocate and multiply. Let's throw in the upper limit, which is 4. So that will be 2 on 3, 4 exponent 3 over 4. And then 4 raised to the power 3 over 4 4 raised to the power 3 over 2 is 8. We have 2 over 3, okay, minus when we throw in the lower limit. So 2 on 3, 4 raised to the power 0. So the lower limit is 1, sorry. So this is 8. So we have 2 over 3 multiplying 8. Then we have 2 on 3 multiplying 4. This will yield 16 over 3. And this will yield 8 over 3. And the final answer will just be 8 on 3. Let's look at the second component function. The second component function is t e exponent negative 1. We are integrating t e exponent negative t, respect to t, from a lower limit of 1 to an upper limit of 4. We are going to use integration by parts. With integration by parts, the integral of u v derivative is equal to u v minus the integral of u derivative v. Let our u be equal to the first part t and our v derivative be equal to e exponent negative t. If u is equal to t, then u derivative will be equal to 1. And if v derivative is equal to e exponent negative t, we integrate that to get the expression for v. And that will be negative e exponent negative t. When you integrate this, you get negative e exponent negative t. Now, let's substitute into the formula. We are going to have the integration of u, which is t, then v derivative, which is e exponent negative t, will be u, which is t, multiplying v, which is negative e exponent negative t, minus the integration of u, which is u derivative, which is 1, multiplying v. So we just write the v because 1 times anything is the same thing. And v is negative e exponent negative t. Let's now continue. This will just be written as minus t e exponent negative t plus the integration of e exponent negative t. And this becomes minus t e exponent negative t, then minus e exponent negative t. We can simplify this by factorizing the e exponent negative t out, and that will be e exponent negative t in brackets. Let's take the negative e out so that we have t plus 1. We can likewise leave the negative in the bracket, but whichever way. So this is the results of integrating the second component function. We go to the last one, which is 1 over t squared. Integration of 1 over t squared dt. Sorry, we have to find the value of this expression from the upper and lower limits. So let's do that before we go to the next component function. So we are going to find the value we have minus e exponent negative t into brackets t plus 1 from a lower limit of 1 to an upper limit of 4. So this will be negative e exponent negative 4 into brackets 4 plus 1, then minus the value when it is the value at the lower limit. That will be negative e exponent negative 1 into brackets 1 plus 1. So this will be minus 5 e exponent negative 4. Then plus 2 e exponent negative 1. So we'll leave it at this stage to represent the results of the integral of the second component function. We can find the values of e exponent negative 4 and e exponent negative 1, but those ones will yield decimals. So we'll leave this one at this stage. Then we move on to the last component function, and that is 1 over t squared. One over t squared, the t from 1 to 4. This can be written as t power negative 2 from 1 to 4. Then, following the rules of the integration, we'll increase the power by 1 and divide by the results. So this will just be negative 1 over negative 1 from a lower limit of 1, upper limit of 4. So this will be negative t raised to the power negative 1 from 1 to 4, or otherwise negative 1 over t from 1 lower limit to upper limit of 4. So this will be negative 1 over 4 minus negative 1 over 1. And this will just be negative 1 over 4 plus 1. And this will be positive 3 over 4. Positive 3 over 4. So let's now bring all our results together into one basket, one vector. So the first one, we had 8 over 3. So that will be 8 over 3i. Then the second one, we had minus 5e exponent negative 4 plus 2e exponent negative 1. So plus the bracket minus 5e exponent negative 4 minus 2e exponent negative 1j. Then the last one is 3 over 4k plus 3 over 4k. Let's look at the next question. We are integrating 4 over t plus 1. That's the first component function with respect to t from a lower limit of 0 to an upper limit of 2. We can bring the 4 out. Then we are integrating 1 over t plus 1 with respect to t. And this will just be 4 ln t plus 1. From a lower limit of 0 to an upper limit of 2. So this will be 4 ln 2 plus 1 minus 4 ln 0 plus 1. And this will just be 4 ln 3. And this will be 0 because we are going to have ln 1. And ln 1 is 0. So our final answer here will be 4 ln 3. Let's look at the next one. We are integrating e exponent t minus 2. E exponent t minus 2 with respect to t from 0 to 2. So this will be e exponent t minus 2 from an upper limit of 2 to a lower limit of 0. Remember, this is a function within a function, so you integrate the exponential function is the same thing. Then you divide through by the differentiation of the top. And when you differentiate the top, the result is 1. When you divide, it will be the same thing. So now we throw in the upper limit. That will be e exponent 2 minus 2. Then take away the value of the lower limit. E exponent 0 minus 2. This will be e exponent 0 minus e exponent negative 2. E exponent 0 is 1 minus e exponent negative 2. So that will be the results of the second component function. Let's look at the last one. T e exponent t. We are integrating t e exponent t respect to t, and the limit are 0 to 2. We shall employ the integration by parts. That's the technique we shall use here. By integrating by parts, it is the integral of u v derivative is equal to u v minus the integral of u derivative v. So let our u be the first part, which is t, and then our v derivative will be e exponent t. This will mean if u is equal to t, then u derivative is equal to 1. And if v derivative is e exponent t, then v, when we integrate this, we'll still get e exponent t. Let's proceed. Now we'll throw in these guys into the formula. So we are going to have the integral of our u, which is t, then our v derivative is e exponent t, is equal to t for our u, then v, which is still e exponent t, minus e exponent t. And this is going to be t e exponent t minus e exponent t. We can factorize our e exponent t out, and this will be e exponent t out t minus 1. Remember, we have limit from 0 to 2. So this will be e squared 2 minus 1. Then minus the lower limit, e to the power 0, 0 minus 1. The value of the upper limit will yield e exponent 2. Then here we are going to have, so minus negative 1. Here the e exponent 0 is 1, so we just have 0 minus 1 in the bracket, which will yield negative 1. And we are already subtracting, so to be minus minus. So our final answer will be e squared plus 1. Now we'll bring all these together into one basket, if I should put it that way, to form the results of our integration. So the first one was for ln 3. For ln 3. Then the next one was 1 minus e exponent negative 2. 1 minus e exponent negative 2. And the last one, we obtain e squared plus 1. E squared plus 1. So this is the result of our integration of our vector function. This is the last session of Unit 1. Remember, let's do some recaps of what we have learned in Unit 1. In Unit 1, we have learned the definition of vector function. We have looked at the limit of vector functions. We have also looked at the domain of vector functions. We have also looked at the continuity of vector functions. We have also looked at the derivatives of vector functions. We also look at the integration of vector functions. See you in Unit 2, where we shall be looking at the application of the derivatives of vector functions. Thank you very much for watching, and don't forget to subscribe to my channel. God richly bless you.